Okay, friends, so we're going to talk about the quadratic formula. And to motivate this, what I want to start with is actually I want to talk about how do you complete the square on a general quadratic ax squared plus bx plus c. Because in my last video, I talked about solving quadratics by completing the square. And in doing this, I promise this is going somewhere, so just go with me. Okay, so first things first, if we're going to complete the square, the first thing that needs to be true is that we need to have just plain old x squared. And I'm going to treat a, b, and c as any number. So I'm going to assume that a is not 1. So just to cover my bases, the first thing that I'm going to do is I'm going to divide everything by a. So I have now x squared plus b over ax plus c over a equals 0. And then the other thing that I want to do to complete this square is I want to subtract this c over a, because usually I want to have just the x's by themselves, right? So we're going to take this c over a and we're just going to bring it over to the other side. So this is going to become x squared plus b over ax equals now negative c over a. Okay, cool. Like I said, this is going somewhere. I promise. This is cool. I mean, it's cool to me. So, all right. Now that I have my variables isolated, all right, what do I do now? Well, now I complete the square. And in completing the square, so first I want to identify what's in the b position. And this is actually kind of an awkward thing to do with how I've written this equation, but just go with me for a second. So what I set equal to b is always whatever is right here. So in this case, my b for completing the square is equal to b over a. So then what's my half b? Well, then I just multiply b over a times 1 over 2. So this will really just become b over 2a. And then I'm going to take 1/2 b and square it. So I really want to square the top and the bottom of this. So maybe I should just write that out so that we don't miss anything. Okay, so when I square this, the top becomes b squared. Remember, I have to square 2, so 2 squared is 4, and a squared is a squared. So this becomes b squared over 4a squared. Okay, so now when I complete the square, and I've done all of this, what do I do with all of this? I take this part and I add it to both sides of the equation. So, okay, let's see. I'll write this over here. So this becomes x squared plus b over ax plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. So I literally took this, I added it to both sides of this equation to get this whole thing. Okay. I feel like I'm running out of space here, so I'll make a little space. Okay, that's much better. So now that I've done that, normally I would factor this side, and actually I'll go back just to our little cheat sheet here. So when you don't know how to factor, so this is what I'm trying to factor, right? So when I don't know how to factor this, one thing I've talked about with completing the square is that you can actually refer back to all of this work. So your factoring is always just x plus whatever your half b is. So in looking at this, this looks weird to factor, so I'm just going to rely on the fact that this is going to be b over 2a. So I can just factor it like that and be done. Now, on this other side, what I want to do is I actually just, this is like a picky math thing, but you know, we like to do pretty math around here. So I want to have just the positive term come before the negative term. So I'm just going to rewrite the other side as b squared over 4a squared minus c over a. Now, I actually want to take this one step farther. So I would like to turn this, I know this is like super awkward on this side, but what I would like to do is I would just like to write this over a common denominator. So let's think about this for a second. I have 4a squared and a, so what's the common denominator between them? Well, it would be 4a squared. That would be the common denominator. So what do I have to multiply this by to get to that common denominator? I would have to multiply the top and bottom by 4a. So let's just go ahead and maybe write this out nicely now. So this will become b squared minus 4ac, right? So c times 4a will be 4ac, so we'll just write it like that. and then all of this over the common denominator of 4a squared. Okay, so now I've done as much as I can with this problem. So now I need to use the square root property. So I'm going to take the square root of both sides, and so this is going to become x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 4a squared. Okay, so let me make a little more space. Okay, so to take the square root of this, I can't take the square root of the top. So remember, it's not a thing. Like, this is not a thing, right? I can't just, when I'm adding or subtracting stuff, I can't just take the square root of these things. I could only do that like if I had something like a squared b, then I could break this out as square root of a squared times square root of b, and then that would be a square root of b. Like, I can only kind of break this up if I have multiplication. When I'm adding or subtracting, this is not a thing, right? So the top I cannot take the square root of, but the bottom I totally can, right? What is the square root of 4a squared? It would be 2a. So let's write this down. X plus b over 2a equals now plus or minus, I'll leave the square root on top, b squared minus 4ac, and now on the bottom this becomes 2a. And that's actually helpful to do because now I need to finish solving for x. So I just need to subtract the b over 2a. So let's see, this becomes negative b over 2a plus or minus this square root of b squared minus 4ac over 2a. And then, hey, look at that, they have the same denominator. So now I can write this as x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, and what is this that we are looking at? This is actually the quadratic formula. So a lot of times when I teach this, I find that most people have heard of the quadratic formula, ta-da, and people don't actually know where does it come from. So all the quadratic formula is, now you know, is it's just really an application of completing the square. That's literally what we did, right? So if I take us back to the beginning, I literally just worked on completing the square of a general quadratic. So this is the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. And if you've ever wondered why the quadratic formula has this plus or minus, now you know. So the quadratic formula in reality, though, is I think it's the least sexy way to solve a quadratic equation, if we could rank those things. But it is a great method to use if you have no other way to solve something. So what I want to do is I want to just use I want to do the quadratic formula a few times, of course. So in general, if you have a quadratic, you want to make sure that it's set equal to 0, like we have here. If it's not set equal to 0, then you need to make it equal to 0. And then you just decide what's in the A, B, and C spot. So in the A spot, i.e. what's attached to x squared, that would just be an invisible 1. In the B spot is a 3, and in the C spot is a 2. So now I am just going to plug my A, B, and C into this formula. So this will become negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 2, all of this over 2 times 1. And I'm already running out of space, so I'll make some space. Okay, so I'm just going to keep going with this. So this is going to become 9 minus 8 over 2. So this becomes negative 3 plus or minus the square root of 1 over 2. What is the square root of 1? It's just 1. So let's see, I'll continue this over here. So this becomes negative 3 plus or minus 1 over 2. And so now what I need to do is I need to really break this into two separate cases. So I'm going to have negative 3 plus 1 over 2 and negative 3 minus 1 over 2. And so what does this become? This becomes negative 2 over 2, which equals negative 1. That's my first solution. And this is negative 4 over 2, which equals negative 2. So my two solutions are negative 1 and negative 2. Okay, so here's the thing. Was this actually the best way to solve this quadratic? No, this was honestly probably the worst way to solve this quadratic because this 100% factors, right? So I could have factored this x plus 2, x plus 1 equals 0, and then I would just have x equals -2 and x equals -1. Now, here's the cool thing. If you're being told that you absolutely must use the quadratic formula, let's pretend that's what I had to do here, then sometimes you can use factoring to check things. But a lot of times, if you can factor something, then you probably wouldn't opt into using the quadratic formula unless you were being forced to do it. So why would I want to use the quadratic formula? Well, let's look at example B. Okay, so this is 2x squared plus 3x plus 5. This is not going to factor. And if you think about how to use completing the square, the first thing I would have to do is I would have to divide everything by 2, and then think about the impact that that's going to have. I'm going to end up having this 3 over 2. This is just going to get really complicated with the fractions. So it's not like I can't do it, but maybe this isn't like my favorite way to complete the square. So I can't factor this. It's not the easiest to complete the square. So this is like the ideal case of using the quadratic formula. Okay, so actually, why don't you pause the video and you try this totally on your own and hit play when you're ready. Remember, math is not a spectator sport. You'll get more out of this if you try it yourself. Okay, so I've got my A, my B, and my C. So I'm just going to set these up in the quadratic formula. Okay, so when I plug this into the quadratic formula, I have -3 plus or minus 3 squared minus 4 times 2 times 5 over 2 times 2. So just double check if you're playing along at home here that these are the things that you plugged in. And so now I'm just going to use the order of operations to work my way through this. So 3 squared is 9, and then let's see, 4 times 2 is 8, 8 times 5 is 40, and 2 times 2 is 4. Okay, so I'll make a little more space. And so let's see, this becomes -3 plus or minus the square root now of -31 over 4. Okay, and so now it's like, what else can I really do with this? The square root of -31, the only thing I can really do with this is break out an I. So this becomes -3 plus or minus I times the square root of 31 over 4. And honestly, like, you really can't do a whole lot more beyond that. I think that most homework systems are going to require you to possibly break this up into like 2 separate fractions, maybe like this. So I could either have 2 separate fractions, or a homework system might make you break out the fact that one of these is positive. So I'd have to get rid of the plus or minus, and then break out the negative. So just a heads up, there are some homework systems that won't let you do the plus or minus. If you're in my class and you write plus or minus on a test, that's totally fine. It's kind of the disconnect between online homework systems and what we take in regular life. But yeah, so this is all we can really do. And so here's the thing. The fact that this is an imaginary number, that actually kind of solidifies like the fact that this cannot be factored, right? So remember in the last example, we got 2 really nice numbers and it factored. And in this case, this can't be factored and we got not nice numbers. So there's kind of a connection there. Okay, so the last example is intended to look a little scary. And I kind of like to take this as a moment also to like think about, is there a better way to do this? So as is, I really don't want to use the quadratic formula, right? Because doing all those calculations with all these fractions, maybe there's a better way. So always think about this, like if something feels like it's going to be insanely hard, sometimes there is a better way. This is exactly one of those moments. So I noticed that there's a bunch of fractions in here, and I know a thing or two about working with fractions and equations. So I know that one way to make an equation easier when it has a bunch of fractions is to do what with it? It's to identify the LCD, the least common denominator of all the fractions. So for 1/2, 1/3, and 5/6, The LCD in this case would be 6. And so then the standard trick at this point is to take each one of these fractions and multiply them by 6. So I'll show you what that looks like. So what did I do? I took each part of the problem, even the 0, just to be consistent. And notice, so I multiplied the first part, the second part, the third part, and even the last part. I multiplied each part by 6. And what does that allow us to do? Well, then notice that each denominator can divide into 6. So for instance, 2 divides into 6 3 times, right? And so what am I left with? I'm left with 3 times 1 times x squared. So what does this become? This is just 3x squared. Okay, so moving on to the next one. 6 times 1/3 x. Well, 3 goes into 6 2 times. So look at what I'm left with. 2 times 1x. That just becomes 2x. Cool. And then finally, I have 6 times 5, 6. So in this case, the 6's just cancel out. And so then I'm just left with the numerator on top, which is 5. And then 0 times 6 is just equal to 0. And so now, I don't know about you, I would much prefer to do the quadratic formula on this situation than this situation. So that's a totally valid trick. And now we can use the quadratic formula. And I can see, so my A is 3, my B is 2, my C is 5. So let's go ahead and do it. So let's see, this becomes -2 plus or minus the square root of 2 squared minus 4 times 3 times 5. All of that divided by 2 times 3. So now, let's see, this is -2 plus or minus the square root of 4 times, what is that, 4 minus 60? Yeah, 60 over 6. So let's see, that becomes -2 plus or minus the square root of 56 over 6. Now, the largest perfect square that goes into 56 is 4. So just to make this clear, so this will be 4 times 14. So that allows me to break down the square roots. So this becomes -2 plus or minus 2 times the square root of 14 over 6. Now let's be careful. I'm actually going to make a little more space to finish this problem. Okay, so I just don't want to get cancellation happy when I'm doing this. So what I'm going to do to make sure that I properly simplify this, and sorry, by the way, if you can hear my sweet doggy barking in the background. Okay, so what I'm going to do is I'm just going to break this up into 2 separate fractions because we don't want to make that fatal error where we just cancel the 6 and one of the 2's. This 6 applies to both this part and this part. So if that confuses your brain, what I recommend is that you break it up like this. And so now I can see, so -2 over 6, this is -1/3, and then this 2 and this 6, so this will just become a 3, and then this is the square root of 14. Okay, and so there is the final answer. Okay, and so with that, I am going to leave it there. Thanks so much for watching, guys. I will catch you in the next video. Bye!